When the sun awakens. Could AR3664 trigger the collapse of civilization? A sunspot the size of a cosmic monster has appeared on our star. It dwarfs the Earth, it twists magnetic fields into chaos, and it has already begun to fire warning shots. But what if the next one doesn't miss? What if history repeats itself? Only this time, we are not ready. A giant awakens on the sun. In the silent vacuum of space, 150 million kilometers from Earth, a titanic blemish has appeared on the surface of the sun. Scientists call it AR3664, short for Active Region 3664. But make no mistake, this is no ordinary sunspot. Measuring over 200,000 kilometers across, more than 15 times the diameter of Earth, AR3664 is now one of the largest and most active sunspots observed in the current solar cycle. And it's still growing. This colossal anomaly is not just a fascinating sight for solar astronomers. It's a potential cosmic harbinger, a warning echoing from history. Because a similar sunspot was once seen before. That was in 1859, and the world would come to know it as the Carrington event, the most powerful solar storm ever recorded. It brought the early telegraph era to its knees. And experts warn, if a storm like that happened today, it would be catastrophic on a scale humanity has never witnessed. What is a sunspot, and why should we care? A sunspot is an area on the sun's surface where magnetic activity is extraordinarily intense. These regions appear dark because they are cooler, about 1,500 Kelvin, or 1,200 degrees Celsius, lower than the surrounding photosphere. Sunspots form when loops of magnetic field lines become tangled and twisted by the sun's roiling plasma. When the tension becomes too great, these fields can snap and release titanic bursts of energy in the form of solar flares, sudden flashes of intense radiation across the electromagnetic spectrum, coronal mass ejections, CME's billion-ton clouds of superheated gas and magnetized particles hurled into space. If Earth lies in the path of such a storm, the effects can be devastating. AR3664, a threat we can see with our own eyes. Sunspots are usually invisible to the naked eye. But AR3664 is different. With the help of certified solar eclipse glasses, you can see this massive region yourself, a black scar against the blinding brilliance of our star. Sunspots of this size are exceedingly rare. They signal powerful magnetic fields that could erupt at any moment. Already, AR3664 has produced multiple M-class and X-class flares, the latter being the most powerful kind known. What are M-class and X-class solar flares? Solar flares are categorized by strength, much like earthquakes or hurricanes. The classification system set by NOAA, National Oceanic and Atmospheric Administration, ranks flares as C-class, minor flares, little to no impact on Earth. M-class, moderate flares that can cause brief radio blackouts and small geomagnetic storms. X-class, the strongest category. These flares can disrupt radio communications, GPS, satellites, and even power grids. Each class is 10 times more powerful than the one before it. X-class flares are dangerous. AR3664 has already released several of them. And one day, one may come directly toward Earth. A history lesson. The Carrington event of 1859. On September 1, 1859, British astronomer Richard Carrington observed a massive flare erupt from a sunspot similar in size and intensity to AR3664. Within 17.6 hours, a geomagnetic storm slammed into Earth with stunning consequences. Telegraph systems sparked and failed across Europe and North America. Telegraph operators were shocked by stray currents. Papers caught fire spontaneously from surging electrical charges. Auroras, normally seen only in the polar regions, lit up the skies as far south as Cuba, Hawaii, and Queensland, Australia. In a world with no electricity beyond telegraph lines, the Carrington event was more a curiosity than a catastrophe. But if it happened today, the results would be unimaginably worse. Modern civilization's weak spot, technology. In the 21st century, we are utterly dependent on electricity and digital technology. A solar superstorm striking today could trigger Massive power grid failures, plunging cities into darkness. GPS and satellite destruction, grounding aircraft, disabling shipping lanes, and halting communication. Banking and financial chaos, as servers crash and transactions freeze. Collapse of supply chains, as everything from ATMs to fuel pumps stop functioning. Loss of refrigeration, spoiling food stocks in homes, stores, and hospitals. Emergency systems offline, including water pumps, radio towers, and fire services. A 2008 report by the U.S. National Academy of Sciences estimated that a modern Carrington-class storm could cause up to $2.6 trillion in damage in the United States alone, with full recovery taking years. Have we been lucky so far? Yes. Despite multiple recent solar flares and CME events, Earth has narrowly avoided direct hits from the worst. Some flares have glanced past us, others missed entirely. But luck runs out. Scientists agree, it's not a matter of if, but when a major solar storm strikes Earth again. Why don't more people know about this? Part of the danger lies in complacency. Most people are unaware of the threat. When surveyed, the majority feel safe from solar activity because they've never experienced such an event. That's the problem. Modern society has no living memory of a true geomagnetic catastrophe. But we've built a digital infrastructure that is incredibly fragile to electromagnetic disruption. We are more vulnerable than ever before and less prepared. Can we predict and prevent the worst? The good news is that scientists and governments are taking action. Tools and agencies dedicated to solar monitoring include NASA's Solar Dynamics Observatory. SDO constantly watches the sun in multiple wavelengths. NOAA's Space Weather Prediction Center. SWPC issues alerts and forecasts for solar storms. ESA's Solar Orbiter and NASA's Parker Solar Probe, studying the sun's surface and corona up close. When sunspots like AR3664 emerge, observatories around the world issue warnings to governments, airlines, power companies, and satellite operators. Some strategies being developed include hardened electrical grids that resist geomagnetic currents, backup satellite systems with radiation shielding, emergency communication networks that don't rely on satellites or traditional infrastructure, solar weather forecasting models to provide advance notice, even if it's just hours. But even with all this effort, response time is short. A fast CME could reach Earth in 15 to 18 hours, in some cases, less than 30 minutes. How can you prepare personally? You don't need a bunker, but basic preparedness can make a real difference. Here's what experts recommend. Keep a week's worth of food and clean water per person. Store backup cash, since ATMs may fail. Have battery-operated or hand-crank radios for news. Keep flashlights, spare batteries, and solar chargers. Prepare an emergency plan for family, pets, and medical needs. Understanding the risk is the first step to resilience. The final warning. AR3664 may just be the beginning. Sunspot AR3664 is not unique, but it may be a warning shot. The current solar cycle, cycle 25, is expected to peak between 2024 and 2025, meaning more large sunspots and flares are likely. The sun operates in 11-year cycles of rising and falling activity. We are now climbing toward the peak, and AR3664 may only be the first of several dangerously active regions. If a Carrington-scale event strikes during this time, our world, so dependent on fragile technology, may not be ready. Conclusion. The invisible storm that could change everything. The threat from the sun is real, constant, and vastly underestimated. What we see as a simple dark spot, AR3664, may be the mouth of a solar cannon, charging up for the next blast. We cannot stop the sun, but we can understand it. We can prepare. We can invest in resilience before disaster strikes. Just as Richard Carrington stared through his telescope in 1859 and saw the beginning of something no one understood, we too are staring at the future. And this time, we have no excuse to ignore the warning signs. Subscribe or follow for more scientific deep dives and real-world risk awareness.